So welcome everybody. My name is Stephen Feuerstein. I'm the PL SQL or the Oracle Developer Advocate for PL SQL, and with me is...
Hi, I'm Chris Saxon. I'm part of Stephen Feuerstein's team. I'm the Developer Advocate for SQL along with Connor McDonald and part of the normal or the traditional answer team on AskTOM. So Stephen, back to you.
Thanks very much. So Chris, his title is Developer Advocate for SQL. He's really a developer advocate for database development. I really am a developer advocate just for PL SQL. I know some SQL, not enough. But our jobs are to help you leverage our technology more completely. Oracle Database has tons of features packed into it, even if you just think about SQL and PL SQL, and there's vastly more. And we want to make sure that when you've got an Oracle Database on your desktop, on your enterprise, you're making the best use of it you can. So we set up the Office Hours program to give you access, direct access to developers, evangelists, product managers, and so on in the organization. And I started up this one on PL SQL 101 to focus on pretty much foundational, fundamental aspects of the PL SQL language. So this week we're going to focus on error management features, but you can ask us questions about anything having to do with SQL and PL SQL, and maybe even beyond that. And maybe Chris will know. If it's PL SQL, probably I will know. You can see we've got a lot of contact information here. We're busy on Twitter, and you can contact us via email, check out our blogs and our videos, and so forth. Now, let's just go over to the Office Hours page for PL SQL 101. So a couple of guidelines. Hopefully you're all on Zoom, watching and listening. We'll keep things muted. Feel free to ask your questions via chat. Chris or I will pick up those questions, bring them into the session. We won't be taking questions on bugs, open SRs, licensing issues. You've got other people inside Oracle to talk to about that. We want to help you get better at the craft of writing applications on top of Oracle Database. If you go to the bottom of the PL SQL 101 page, you'll notice a list of resources. So there are some general resources for you to take advantage of. There are also specific ones for this week. 9 good to knows about PL SQL error management. My blog post that I'm going to use in just a few moments, talking about some of the high-level topics you need to be aware of. PL SQL 101 Error Management and Planning for Trouble are 2 articles from Oracle Magazine I encourage you to check out. And of course, there are many, many more resources on exception management in Oracle. But this way, right on this page, you've got a couple of quick links that you can access. Also, we'd love to get your feedback on the session, preferably after it's done. Give us your rating, how we can improve for next time. And you're always welcome to ask us questions, and we'll take them up, obviously, in the call today. Okay. Chris, anything else? Any other intros before we dive in?
Anything else to add at the moment? No?
Okay. Then I'm going to surprise everybody, maybe, and start us off with a quiz. So, time for you to do some work. Hopefully it's not 5 a.m. in the morning where you are. So here's a block of code that declares a variable. Within the main block has a nested block in which I assign a value to the variable, trap the exception, et cetera, et cetera. So the question is, what will you see on the screen when this block executes? Use your chat window to type in an answer. We'll give it a couple of minutes or a minute or so and go from there. And the reason I like to offer this quiz and lots of other quizzes on the Dev Gym and other places is that it's really important for you to be able to read code and analyze and say to yourself, what is this code going to do? And when you have that kind of confidence and knowledge about the language you're working with, you can much more effectively write and debug. So our first entry has come in, and it says big string plus what error. Okay, it displays big string, and then it says what error. We've got a second one, inner block and what error. I've got another inner block and what error. Just inner block. One of the things that fascinates me about this quiz, which is a fairly simple one for error management, is that even with a relatively small number of developers, we'll get a pretty wide variety of answers, sometimes changing them along the way. So I've got somebody back to, let's see, inner block and what error. All right, so thanks for all those answers. Let's take a look. Chris, what do you think we're going to see when we run this code, and why?
You're putting me on the spot here.
On the spot.
So as you see, you've declared that variable as a varchar 25, but big string is slightly longer than that, 7 or 8 characters long. So we're going to hit the value error when you assign that. So I believe we will hit that value error in the first inner block value error and then get to the what error.
Right. So let's see. Let's take a look with my pen. So I assign a value to a name, big string. It's longer than 5 characters in length. So it blows up. The PL SQL runtime engine raises a value error exception. So the way things work in PL SQL, it doesn't say, it's not big enough, but we're okay. We'll give you the first 5 and keep going. It says, no, this doesn't work. So the rest of this block terminates. It's done. There's an exception handler for that block. So it checks for a match, and it does find a match by name. We could have had when others as well, and it would have trapped it. So then it displays inner block. Now here's the thing. Inside that exception handler, I don't re-raise the exception. So this block is now done, but it simply passes control back to the outer block, and it keeps on going because nobody told it that there was an error. So then it displays what error. And this exception handler down here never comes into effect. All right, well, I know you like that so much that you want another one. So let's do one more. Then we'll dive in some of the content, and we'll take your questions. So what will I see on the screen when I execute this block of code? Got a couple of outer block answers rolling in.
Yep.
Anybody else?
Everyone's thinking about it.
Now they're thinking, I didn't get it quite right last time. Maybe I shouldn't say anything this time. Yes, yes. I see a consensus rolling in. We have a consensus. I like consensus some of the times. So the consensus was outer block. Let's take a look. Just that. So what's different about this block than the previous one? Chris?
So you're actually assigning it in the declaration section. So right at the top there, you're assigning big string to that new variable that you got. And the interesting thing about in the declaration section is that any errors raised there aren't handled within that kind of local exception handler. It goes out to whatever the call, whatever's surrounding it, the outer program, which in this case is your exception handler there.
Right. So here's the key thing. When an exception is raised in the declaration section, this exception section doesn't play any role whatever in possibly handling the exception. This exception section is really only possibly handling exceptions in the executable section right here, which it never even gets to. So the exception comes out unhandled this time, which causes the outer block to terminate as well, comes down here, finds a match, displays outer block. Oh my gosh, who could have known that PL SQL was so much fun? All right, so let's take a look at some 9 good to knows. I'm just gonna go through these, I'm gonna save them, and then we can, as you'll see, go to Live SQL scripts, take your questions, etc. So here are 9 things that I think are very good to know about PL SQL error management. First of all, as I just mentioned, exceptions raised in the declaration section are not handled in the exception section at all, which raises a number of interesting nuances in the way you might want to write your code. An exception raised, no, I don't need to subscribe, thank you. An exception raised does not automatically roll back uncommitted data to tables. So just because an exception is raised doesn't mean that anything that's uncommitted in your session is going to be rolled back. Usually, the rollback occurs when it comes out completely unhandled from the PL SQL engine, or you explicitly force a rollback. I don't want you to do that. Leave me alone. Wow. You can and should name unnamed Oracle errors. So Oracle gives us a lot of named exceptions like no data found and value error, but sometimes you need to reference an error code by its number. And you really want to avoid that or minimize or control how you do it, usually by assigning a name to that number with exception in it and still working with a name, but it's your name. You can name our exceptions. If you do not raise an exception in your exception handler, the outer block doesn't know that an error has occurred. That's what we just saw in PowerPoint in the first quiz. If I do not re-raise the exception, then the outer block thinks we're good, we keep going. And back to. Whenever you log an error, capture the call stack, error code, error stack, and backtrace. So in general, and we'll talk about this further, when you're handling an exception, usually what you want to do is record what happened so that you can diagnose it and fix it, hopefully, really, really soon. So we need to gather all the information that would be useful for somebody to diagnose the problem. And besides the application-specific stuff, which you always want to make sure you store, is the execution call stack, answering the question, how did I get here? The format error stack, which is what is my error message or stack, similar to SQL error message, but we recommend this one instead, or even better, using util call stack's new package API. And my favorite, format error backtrace, which gives you the line number, traces back to the line number on which the error was raised. Okay, and number 6, always log your error and backtrace before re-raising the exception. So basically, if you have to re-raise an exception, you want to log the error, get your backtrace information, and store it before you re-raise, because you'll lose that original backtrace. Use compile time warnings to give you information about your exception handling and how to approve it, especially avoiding when others than null are swallowing up your exceptions. And then we'll get into more specialized topics, which we can explore if you have more interest. Use log errors to suppress SQL errors at the row level. So using the log errors feature in SQL, you can actually say if an error occurs at the row level of a statement, swallow it up, write a message out to the log table, and keep on going. So suppress it at the row level. The only way I know to do that. And finally, if you do need to send an application-specific error message to your users, use raised application error. You specify the error number and the error message, and that way you can override the standard no data found messages or things from inside Oracle that you don't really want your users to see. So lots we can cover. Let's see if we've got any questions.
So yes, someone came in right at the start, actually. They were asking a good question. A good question. They want to insert 100 rows into a table, but what happens if like the 50th one stops? So they got halfway through. There's some problem with the 50th one, but they want to keep processing and keep going for the rest of them. You know, how can they do this? What can they do to avoid the problem?
So let's talk in some generalities, and then let's take a look at some code. Let's see, I'm going to spotlight my video. Chris, actually, can you spotlight my video? I'm still seeing you, and I'm talking.
Yeah, it's fine. I see you. It's okay. Yeah,
okay, great. Of course, I wouldn't be seeing myself. So you're talking about needing to insert, let's say, 100 or 1,000 rows or 10,000 rows, doing some batch updating. And you have a requirement, which is that if any one of those single changes fail, you want to keep on going. So there are a number of ways that you can think about doing this. One is if you're doing row by row DML, so I've got a cursor for loop, and for each iteration of the body, I'm going to insert a row or update a row. You could put a begin end around that DML statement, stop the propagation of the error, and then log the error and keep on going. What do you think of that idea, Chris?
So I think, you know, if that's what you're doing and for some reason you have to be doing the cursor for loop, then that's a valid way. But I think you should step back and ask, do you really need to have that loop? Do you need to be processing them one at a time? Can you either do it with a single statement, like you just insert, you add the select statement, so you've got select whatever data it is and insert it directly into one table in one query. Now, there may be situations where you can't do that, and if you are in those, you should look at bulk collection, where you've got to load the data into an array and then do whatever processing you need to before inserting it. So there's two kind of alternatives I'd suggest there, and they've each got their own way of handling those errors. Do you want to?
Yeah, so Chris, I think, is exactly right that if you're ever looking at a situation where you're doing row by row DML, I've got some kind of loop, and inside that loop, I'm doing individual DML statements, a flag should be raised. You should be looking at that code for two reasons. Well, mainly for one reason, the performance. So if you've got a trivial number of rows, you're updating 25 rows or 30 rows, you know, it probably doesn't really matter. If you want to stick with the row by row processing, go ahead. But in any non-trivial volume of data, it's going to be a very slow way for your code to execute because you're switching between the PL SQL and SQL engines, context switches. Now, Chris's first point is, if you can do it in SQL, straight SQL, do it in SQL. Don't even use any kind of PL SQL constructs, loops, and so on. The problem with that is that PL SQL statements are generally all or nothing. So if I issue an insert select from another table, either all those rows go in or none of those rows go in. Now, you could look at using log errors to suppress errors at the row level, and we can take a look at examples of that. But in a situation where you need to do statement level exception management, not individual row levels, then using FORALL is a great alternative to that. Now, what I'm going to do is share screen again, and I'm going to go over to Live SQL. And let's take a look at scripts with FORALL. So livesql.oracle.com is a website available to you 24/7 to access, play around with, learn about Oracle database, and specifically SQL and PL SQL. And we are now running on 18C, so you can check out 18C new features. We'll even show you some today, if you ask. Now, one of the other really great things about Live SQL is that we offer a code library. So you can just come here and search for stuff. For example, I'm going to search for FORALL. And we can see lots of different examples. So let's go into save exceptions in FORALL and exploration. I'm going to sign in. And, well, I'll come back to that in a moment. You can see we've got a whole code library we can search through. I've actually got about 200 scripts on PL SQL in here. So we've got FORALL with, here's an incremental commit processing with FORALL. Oh, it's actually not the one I want. Sorry. Save exceptions in FORALL.
So before you get more into this, someone's asked, can you briefly explain what FORALL is?
This should be perfect for that. Great. Let's explain what FORALL is. So again, by the way, what I'm showing you these resources like the 9 good to knows, which is part of your 101 office hours with all these live SQL links so that you can come back and do all these things yourself and verify this, run the code, try it out, download the code, use it in your own environment. Okay, let's take a look. So here's the basic idea behind FORALL. I could have a for loop that says for each row in my table, execute this update statement and loop. And if you move beyond a trivial number of errors, a trivial number of rows, you'll see a pretty significant performance slowdown, especially compared to doing it straight in SQL. So what you can do is change your for loop into a FORALL statement. The most common form of FORALL looks like a for loop. You've got an index going from usually 1 to the count in an array. And then within that FORALL statement, and it's a single statement, I've got a DML statement. And I reference somewhere and possibly multiple places in that FORALL statement, the array with the iterator. And what this does is tell the PL SQL engine, when it sees FORALL instead of a for loop, so let's say there are 1,000 elements in that array. It basically pre-creates 1,000 different update statements, passes them over to the SQL engine with one context switch. Over on the SQL engine, it then unpacks that delivery of those actually a single statement with 1,000 bind variable values. And then it runs through all those different updates. So it's still going to do the same work on the SQL side. We'll still do 1,000 update statements, but it won't go back and forth between the SQL and PL SQL engines. And when it's done processing all those update statements, it will pass the information back to the PL SQL engine. So that in a nutshell is FORALL. It's a syntactic change. It's a different way that you can write essentially a loop that tells the PL SQL runtime engine to follow a very different path of behavior. Again, almost nothing changes on the SQL side. It's simply a matter of how the PL SQL engine interacts with the SQL engine. Chris, anything you'd want to add to that?
No, I think that's a good summary of how that works.
Excellent. Now, in general, a FORALL statement works like a insert select. In other words, the first time, let's say I'm going through 1,000 update statements, the first time one of these update statements violates some rule on my table, a check constraint, a foreign key violation, whatever, this FORALL statement will stop. An exception will be raised. It's actually the -24,381 exception. Notice I've given it a name in my package, so I can, if I choose to, handle it by name, and you'll see that below. But that exception was raised, and then, oh, I'm sorry, actually, it doesn't raise -24,381. It'll raise whatever exception is caused by that failed DML statement. So that's fine, and then everything stops. That's consistent with normal SQL all-in-one behavior. But going back to the original question, what if you want to keep going? What if I want to execute all 1,000 update statements, even if some of them fail, even if all of them fail? So in that case, what you'll do with FORALL is add save exceptions. And it's pretty much what it says. When you run this code, if it hits any errors along the way, and you can see that some of these names are just too big for my poor little table in the employees table. So it says, no worries, save the exception, keep on going. It'll go through all 1,000 statements, try every single one. And then if any one of them failed, it raises, yes, indeed, minus 24,381. So what I can then do is write an exception handler that traps for that specific named exception. Don't say if SQL code equals negative 24,381. That's scary and confusing for everybody else in like the whole world. And once you're in that exception handler, you can iterate through a special pseudo collection that Oracle has created with an individual element for each one of the statements that failed. And then you can log the errors, or in this case, just display them, but of course you want to log them. And then you can log each individual error. You could even say, if the code, the error code, because it stores the error code, if the error code is a certain one, like -1, oh, that's a dupe valid index, let me try to recover with a different statement. And you can actually do statement by statement recovery if that's appropriate. So that's a way that you use save exceptions with FORALL to keep on going, but still get the benefit of that bulk processing. All right. Any other questions?
So, well, just while we stick with FORALL, there's a follow-up explaining FORALL. They're saying, can I replace my for loops with FORALL? That's a good question.
Can I explain my for loops with FORALL?
Can I replace, so if you've got for select star from whatever loop, can you then replace that with FORALL?
Right, okay, so can I replace all my for loops with FORALL?
Yes.
Well, I'd say in general, you want to avoid any sort of blanket declarations about anything in code. That's been my experience from life. And first of all, of course, many of your loops have nothing to do with DML. So if your for loops, let me put it this way. If your for loop has a DML statement inside it, an insert, update, or delete, that should be a prime candidate for conversion to FORALL. In other words, it should be a prime candidate for conversion to set level or bulk processing. The first step is, can I do it in a single SQL statement? Because in many cases, you do want an all or one situation. I want all of them to work or none of them to work. And if that's the case, doing it straight in SQL and then just having a single exception handler around that one high-level statement is going to be your most efficient solution. If you do need more nuances, and there are a couple of nuances that involve the invocation of FORALL, and we'll do a separate office hours on bulk processing at some point too. But if you have a couple of different nuances, one is, well, I have that row by row or statement by statement suppression needed, then you can't go with just the straight SQL unless you look at log errors, and we can take a look at that too. But the other thing is that in many cases inside your for loop, you might be doing iteration by iteration special procedural logic in PL SQL, preparing the values that go into the SQL statement, changing some other aspects. And in that case, you may not be able to switch to pure SQL because you need that statement by statement interruption and processing. So in that case, what you're going to do is switch to a FORALL. But before that, before the FORALL, you're going to have a for loop or some kind of processing section that does all the PL SQL work, collects all the information just as you need it in an array, and then the FORALL statement merely pushes the data into the table through the high-level interface. So in general, yes, I think you want to take a look at moving away from for loops with DML inside them. Then you have to make a careful decision about what would be the best solution.
I think that's a good approach. So I think if we kind of mentioned log errors a little bit. So if we've got the single statement, I think that's worth going into in a bit more detail, because we had someone asking about that. Will it not roll back or discard the array, only skip the error records? And I think that's kind of log errors is to do with single statements, as I think you're going to show us here now, isn't it?
You bet. So once again, because this is such a great resource, I'm going to use Live SQL. I'm going to show you a script that either I've written or somebody else has written. Use this website. It's a great resource. So let's take a look at log errors. So with the log errors approach, basically what you're going to do is create an error logging table that goes along with your DML table. And then Oracle will automatically put stuff into that table. So here's the interface, dbms error log, that's the package. Create my error log table. I specify the DML table name. And what it does is create a table by default called error $_ employees. Now, you can change that to be whatever name you want, but that's the default. We'll just go with the defaults for today. And what you'll see is that it creates a table that always has the same first 5 columns. Basically, the error information is going to grab what's the error number, what's the error message, the row ID, the operation type, IUD, some custom tag information you can provide. And then for any column that's compatible with varchar2, in other words, it can implicitly convert to varchar2, Oracle also creates a column in that table in a varchar2 form. It basically will store the representation of your values at the time the error occurred. Okay, so without log errors, SQL is all or nothing. So for example, I've got a little block of code here that says, let's give everybody really big raises. I'm going to multiply their salary by 200. We had a great year. The cloud is bursting out. So if I look at how many people are making that much money now, in other words, salary greater than 24,000 from the standard employees table, I find that there's nobody making that much money. I then apply the really big fat update. Yay! Oh, wait a minute. There was at least one person for whom multiplying their salary by 200 busted out the constraint on that table, on that column. The value is too big for the specified precision. That caused this entire block to shut down, this exception handler to trap, and then it shows me how many people are now making 24,000 or more, and none. Because anybody whose salary was changed along the way inside the single DML statement, those changes were rolled back. That's the way the SQL engine works. Okay, let's suppose that's not what we want. Let's suppose we're doing a mass bulk update. We can do it in a straight single SQL statement. We've got all the memory we need inside the database to do it. Then what I can do is add log errors. And I can say even the rejection limit. So I might say, for example, I don't care how many go wrong, just keep on going. I might say, you know what, if I hit 100 errors out of my 10,000, something's badly wrong. There shouldn't be any more than that. So let's stop. But reject limit unlimited. So it's a part of the SQL engine, the SQL layer, not PL SQL. And then if I run that same code again, the only change being log errors and no exception handler. No exception handler at all. Before I have 0 people making that much money. Afterwards, I updated 49 rows. So that's how many the SQL row count tells me. How many were changed in the table? 49. Now, the employees table has 107 rows in it. That means that 58 people couldn't get that raise for them. And here's how we can know. I can select from the error $employees table. I find my 58 rows. I can even look, of course, at the details. In this case, they'll have the same error, different row IDs, and you can see that we track the values from the table. So you can go back and look at what the values were at the time the error occurred. So that's the basic idea behind log errors. Probably the most important thing to remember about log errors is that if you use it, the responsibility is on you to say, wait a minute, I finished. No exception was raised. I need to check my table. If you don't check the table right after your DML statement runs, you'll never know if you caused those errors and if everything went right. Okay? You also have to manage that table yourself. Delete from the table when you're done, and so on. So that's log errors in a nutshell. Let's see if we've got any follow-up questions from that. Or any other comments from Chris?
Yeah, so I think that's a good summary of log errors, and it's, they say it's a really useful way to move to that set-based processing, because I think that's one thing a lot of people get caught up in. They kind of go, well, I've got this loop approach or maybe bulk collect, and they go, well, hang on, but I know or expect some errors a proportion of the time. So log errors is a good way to kind of get out of that. But let's go back. So someone's, it's not really a finished question here. They're asking about using rollback and save point. And I think that's something that's perhaps not so relevant. So Ahmed, if you could give a bit more information about what you're asking about rollback and save point, we can come back to that. But there's a question about performance, which I think we'll come back to in a minute. But before that, someone's asking the drawback of raise exception. I found that exception when others then null overwrite raise application error. So it sounds like they're raising an exception using raise application error and then doing a when others null afterwards, which sounds a bit fishy to me. But you got anything you want to?
So a drawback of raise exception, I found that the exception when others than null overwrites raise application error. So in general, if you trap an exception and inside that exception handler, you raise another exception, then whatever came in before that is gone, or it'll be part of the error stack, but it won't be the primary error code and message that a user will see, or that is, in the end, logged out to your log table. So certainly, if you say when others then null, well, if you say when others then null, then you're swallowing up the exception. So whatever was propagating out of the block, it stops dead. And you're saying, I don't care what went wrong, keep on going. Now, there are times when you may want to actually say that. That's okay. Usually, you don't want to say when others then null. You want to say when others or when specific exception, log the error, and then choose to continue. So you want to have a record that something went wrong. But in general, it's absolutely right. If you don't re-raise the same exception with a raise semicolon statement or raise another exception, it's swallowed up, gone forever.
Yeah. Yes, as you're saying, log errors can hide a problem. I think people forget that if you've got with when others, you can have like IO exceptions or kind of database corruptions. And they're just thinking about the errors that they expect. And of course, that all disappears. And potentially, you can end up with a situation with a corrupted database and you just don't know about it for some period of time.
But I've got to say, there are certainly some errors are so bad that they will actually override when others and just stop things entirely. It's documented. Some people are very unhappy with that, but that's certainly the way it works right now. But in general, yeah, you will hide some of the most important stuff that's going on in your application if you choose to say things like when others then, or forget about when others then null. When others then dbms output line. You might say, cool, I'm going to see a message when something goes wrong. First of all, did you re-raise the exception? Second of all, in production, dbms output line is not going to be your friend. So you always want to write stuff out to a table through an autonomous transaction procedure as part of your generic logging utilities.
Yeah, so someone's saying, did you just say that you might want to use when others then null, and in what circumstances? I'm not sure that's what we're saying here, is it?
Well, I think that might have slipped out of my mouth. No, I would say you should never use when others then null. That's too extreme. Well, I'll tell you when I've used it. I might be building some scripts to apply changes from dev to test to production, and I'm going to add a column. So alter table, add column. And I'm going to be running the script multiple times at least, well, hopefully not in production, but in stage I might be running it multiple times. So I might have already created the column and not rolled back the DDL change. So the next time I run it, I'm not worried if the column already exists. So I'll just say when others then null. I shouldn't. I should say what exception will occur if the column already exists. I should trap that exception specifically and otherwise let the exception propagate out. So I'd say the only times you should ever see when others then null in your code is when you want to show people really bad code, when you're really lazy like me too often, or you're just writing some one-off script and you don't really care. Other than that, yeah, don't do that.
Yeah, but there may be some situations where keeping the code going is more important, and in that case, logging the exception may be a valid approach, because you still want to know something went wrong, something happened here, and then you have some way to actually find that out and get that information.
Well, my experience more and more is that you want to keep track of everything that's going on in your application. It's sort of like the big data approach to life. I think I have a lot of ethical problems with how big data is taking over people's lives, invading our privacies, et cetera. But I think it makes sense that the more data you have, the more information you have to act on. So for example, the autonomous database that we're building, we're going to be gathering tons and tons of data from all over the place inside the database so that our engine can do all this great work for you autonomously. Similarly, when in the Dev Gym, the Oracle Dev Gym is a quiz workout class platform that I'm one of the main backend developers for, that's also powering AskTOM Office Hours. And at this point, when I do almost anything, for example, I have a lot of jobs running in the background, kicking out emails and doing processing, I'm always writing out to my system log, even if it's just information. Hey, I started this. Hey, I ended this, so that I have a record of what was going on inside the application. I don't think you can overdo that. As Tom Kite once said, he's happy when the volume of his instrumentation code is greater than his application code. I don't think I'm there yet, but I'm pretty happy to just throw lots and lots more instrumentation in there.
Yeah.
Wow, we have a lot of comments here.
Yeah. So Deepankar, I think we'll come to your question about performance in a minute. We will come to it. But before that, someone's asking a bit more about the error dollar log tables and saying, is it good practice and we do it for each PL SQL block? Because we'll end up with a huge number of these error dollar tables. And the thing is, you create it for the table, don't you, Stephen, rather than...
Right, it's created for the table. First of all, when it comes to log errors, I would say that it's going to be very rare that you're going to use the log error feature. If it's you should not be thinking about using it all over the place for a very important reason. What it does, it's suppressing errors at the row level. I think there are, so in other words, if I say update the employees table, set salary equal to salary plus 0.1 or times 0.1, so getting a 10% raise. You want everybody to get it or nobody to get it. If that's the rule, and that's usually the rule for a DML statement, you don't want log errors because then you might have essentially partial updates. So log errors, I think, is a very specialized and very powerful feature to be used with great care. While we're on log errors, so one of the problems that you actually have using the log errors feature as it's defined is that the information that we generate about what happened is actually incomplete. I'm sorry to say this to you, but we didn't quite finish the job. For example, inside the error log table, it doesn't say when it happened or who did it. Wow, really? That's not good. So one of the questions that one of the attendees asked is, can I put an after insert trigger on the error log table? So here's the thing. The log errors table is kind of deficient in a couple of important ways, but it's just a persistent database table. You can even create the table yourself, not using DBMS error log create error log. As long as your table has these 5 columns, it works. And what you can do is add additional columns like who did this, when it happened, where it happened in my code. And then you can create triggers to populate them. And I'm pretty sure I've got an example here for you. So search for log errors, helper package. So this is a package I wrote that does all the things that you'd want to do to fix the problems with log errors. I'll just run through this code very briefly. It's a great example of using dynamic PL SQL as well. Dynamic SQL and dynamic PL SQL and dynamic DDL. So what I'm going to do is use my own create objects to create the DML, the error logging table. And what I'll do is create the table. And here are the things you'd want to do in a production environment with log errors. I'm going to then alter the table and add 3 columns. Who did it, when it happened, and where did it happen in my code? And then I'm going to create a trigger that populates those columns for that table. And this, I think, is actually pretty critical to using log errors effectively. So yes, you can create triggers on these tables. You can basically patch up what was left out from the core log errors functionality. But again, I would say that in general, you certainly don't want to change all of your SQL to using SQL with log errors. There should be a specific requirement for essentially allowing a partial DML statement to complete. What else have we got?
Okay, so I think we should come to this question about performance. So they're asking, can temporary table give good performance benefit compared to using a collection for temporary processing of rows? So we need to stage the data somewhere before passing it to doing the final insert or whatever it is. So I've got some thoughts on that, but I don't know if you want to. Yeah. So this is one of the things where there isn't really a straightforward answer, because there's a couple of things to bear in mind. If you're writing to a temporary table, then you've got an extra insert to stick the data in there. It's going to go in the temporary table space. So you're doing extra work there. But if you're processing a large volume of data and you're collecting it into an array, potentially you're going to hit memory limits. So this is one where you've got to really look at what you're doing and how it's processing. So by writing it to a temporary table, you're going to have extra SQL statements. You've got to select it into the temporary table, do whatever it is, and select it back out, versus bulk processing where you just select it into your array and then do the FORALL processing. Where exactly that trade-off lies and how it's going to work for your application is very situational dependent. And I'm not aware of us having a particular guideline on when one is better than the other. So I don't know if you've got anything you want to add to that, Stephen.
Not much. It's certainly, I think it's a classically good question with a classically frustrating answer. It depends. What I've seen, I have to admit, I haven't used global temporary tables very much at all. I like collections. And in general, when I work with collections, I'm not working with massive amounts of data. So for me, the collection has been the go-to solution. It'll be faster than using the global temporary table in general for just, it obviously it partially depends on what you're doing with the data in that table. If you need to do a lot of SQL operations, then you probably want to use a global temporary table. If you have a procedural piece of code that's building up that data set, then it would argue pretty strenuously for using a collection, watching out for the PGA consumption. But even if you use a collection, let's say a nested table or VArray, or now as of 12c, an associative array, you can put those inside a table operator. I can say select star from table, and inside table have my array. And I can even use that array in SQL. So even though I haven't created a global temporary table, I can select from it, I can join to it just as I would a global temporary table. So in that sense, you might have the best of both worlds that way as well.
Yeah. Yeah, so I think that's good. Yeah, so I'm sorry about this, but I think really it just comes down. I think the first thing to do is look at what you're trying to achieve, because sometimes, as Stephen's kind of saying, the business or the way you're implementing your algorithm or the business requirement will guide you down a particular path, because it will be the easier way to do it. Do that, assess the performance, and ask, is this good enough? If the answer is yes, you're done. I think a lot of people get a bit worked up and kind of go, "Oh, could it be faster?" And it's like, well, does it meet your performance needs?
Is it fast enough? Right.
Is it fast? If the answer is yes, then you don't need to worry about it. It's only start looking at other options when you've found that it isn't fast enough. If it's a background batch job, a lot of people don't necessarily care that it takes a minute, 10 minutes to run.
Mm-hmm.
Versus if it's actually someone waiting on a screen for it, anything over a couple of seconds is, probably too long. So you've got to look at your requirements there.
And there's one comment here from Pete. My guess, temporary tables will be more consistent in performance and more conceptual, readable, in maintenance. Collections are in PGA, and that can be more sensitive to memory and CPU load. Those are really good points. I really like your point about conceptual, readable, and maintenance. So assuming you're not writing crazy SQL like the kind of stuff that Chris Saxon is so great at, and Connor McDonald and so forth, assuming you're writing like, somewhat readable SQL anyway, having your global temporary table and doing a SQL operation probably will be more readable and certainly less code than what you're taking to populate and manipulate a collection. Of course, it still depends, but I can see that being a really useful point to keep in mind. In terms of more consistent in performance, I suppose, I'm not sure about that, because in a sense, relying on PGA, assuming you're not blowing out your PGA, it's a relatively small amount of PGA, it seems like your per session consistency will be potentially greater than having to make it play in the bigger space with the global temporary table.
Yeah, I'm not sure exactly where it would lie on the consistency. I think one thing I would say about global temporary tables is that it can be if you've got big changes in your data set. So sometimes you run the process and it processes 10 rows, and sometimes you run the process and it affects 10,000 rows. You've got big swing in how much data you're actually working with. And in the past, basically the database just guessed how many rows were in that table. And this can lead to suboptimal execution plans. And since you've got this big swing in your data set, what's actually there, that can lead to more inconsistent performance. But if you're processing similar amounts of data at the same time, I'm not sure. Again, I think it's one of those, you've got to look at your requirements, what you're doing, test it out.
And of course, that's going to be generally true of anything we talk about, whether it's error management, using FORALL, collections, et cetera. You want to have a very good understanding of what your user requirements are, a very good understanding of your environment in which you're running your code and your data. and make the decisions based on all of those factors. So Chris, there's a question here. How can we handle table lock issues while using DML statements within the PL/SQL code block?
Okay, so I think it's first question is what kind of lock issues are you looking at? Because so we've got our inserts, updates, and deletes. When it comes to doing an insert, that shouldn't really block anything else unless you've got multiple sessions which are inserting the same primary or unique keys. When they have to wait, to make sure there's not a violation there. Inserts you can have as many inserts kind of concurrently going, and you really don't have to worry about it. When it comes to updates in particular, you have to be very careful in how you're writing your code. So if Stephen's updating everyone's salary to give them a 10% raise, but I'm updating Joe's salary because he's now just changed job, he's received a promotion, so he's getting a particular salary raise for him. The order you run those updates, you've got to think very carefully about what you want to happen. Are we giving everyone a 10% raise and then giving Joe a raise on top of that? Or are we giving Joe a raise and then a 10% increase on top of the raise he just got that everyone else is receiving? Now, whichever one of us starts the update first is going to block the other. So I'll update Joe's row. That row is now locked. Stephen tries to update everyone's row. Those rows are all locked. And if it's the same, or he's waiting for me to release the lock on Joe. So I need to commit or roll back for him to do the update. But then we've given Joe a raise because he's got a promotion, and then giving him a 10% increase. Whereas if Stephen happens to run the update first, he's locked all the rows. I've got to wait for him to commit to issue that update.
And so the order is important from the application standpoint in terms of the actual what's going to happen in your code. So somebody's going to be waiting. So I'm running my I clicked submit, raise, and I'm sitting there. The user's like, what the heck is going? This usually takes like a second. So what's happening, correct me if I'm wrong, is that my update is waiting for that other update or whatever to finish before I can proceed. And just sit there and wait until it actually times out or is able to proceed. Is there any way to get it to not time out? Yes. I mean, to not wait. Sorry, not wait.
Yes. So, well, what you can do is if you're trying to run an update and you think, and it's likely that there are going to be conflicting or concurrent updates, what you can do is mark your intent to update a row with select for update. So you're not actually updating the row at that point. You just say, I want to update this row at some point later in my code. And when you do that, there are some options available to you on what you do if someone else already has that row or a subset of the rows you want to update locked. You can do a for update no wait, which basically just says if it's blocked, bail out, get out, and give an error, so that you now tell the user someone else is updating this information, please come back again later or retry later. Another option you can do is you can do a for update, but you can skip the locked rows. Now this is one, again, where you need to be really careful about what it is you're really trying to do. If Stephen's trying to give everyone a 10% update raise, I've got Joe's row locked and he skips it, has Joe just missed out on his extra 10% that everyone else has got? So you need to be quite careful here. This is where you need to think about, again, your business logic and what should happen. But the select for update allows you to kind of stop early if you need to. You want to say anything else on that? Or?
I think that covers it. We had a note from Dennis. The thing Chris just described to my mind should be the concerned decision. It's a good idea to select for update first, right? So basically, make sure you've got your order in place. Make sure if you think it's likely that you're going to hit a conflict and you don't want to have that user sitting there and waiting, you can do the select for update and not wait for the timeout. and even put it in a little loop. You could even set up a little latching process of your own to try again, though that has its own interesting associated with it as well.
Yes.
Yeah. All right, let's see. So we've got 10 minutes left. Hopefully we'll have some other questions coming on in, and please can ask about error management or whatever else. I'm going to talk, because I like to talk. I'm going to talk about something else, which is, I think, some high-level comments about error management. First of all, and I wanted to raise this with all of you because I was surprised when I went to a recent conference at how few people are doing this. So let's actually look at my code. We're going to take a look at one of the back-end packages of the DevGem.
That is brave, Stephen, showing you.
Yes, I am brave or crazy or something, and I'll make my code bigger. Whoops. So,
can you share your screen?
I could even share my screen. What an idea. Thank you. It's so good having a partner on these things. Let's see. Share my screen back to.
There we go. Yes.
My packages. Oh yeah, 80,000 lines long, whatever. So let's look for one others. Okay. So here's an example of what I do inside my backend code. And so here's the pattern that you want to be following. Don't worry about the specifics of my code. When something goes wrong, whether it's one others or you have a specific exception handler, what you never want to do is say insert into log table, commit, or gather up all this, call dbms utility format call stack, call format error stack, call format error trace, and write them out to a table. None of that. What you want to do is have a single procedure. For example, mine is called syslog error or log error. And I pass the information, what the context is, the title, the specific values I want to save. I could even tell it to raise, but in general I don't. I re-raise here to propagate the same exception back out. But these are the key things you need. A generic procedure that does all the work for you. So inside this procedure, I call format error backtrace, stack, call stack, et cetera, et cetera. I gather all the generic information I can, stick it in the table. Me as the application developer here, I don't have to do that every time. The generic utility does it for me. What I add are the context-specific values, the values from my local block of code that will be lost when the exception propagates out. So in general, my approach is to log an exception as close as possible to where it occurred inside that block of code. I log my local state of my application. I propagate the exception out. Some cases I won't propagate. For example, when I send an email, if a failure occurs by sending an email as part of a process, I never allow the exception to propagate. The email didn't go out. Probably not the end of the world. But in general, you want to log the error and re-raise. So the reason I wanted to raise this with you is that when I gave my talk in RMUG recently, a lot of the people in the audience didn't have a generic reusable error logger like this, and that really concerns me. And part of the reason it concerned me is that you don't have to build one yourself. So if you go to GitHub, just search for GitHub and Logger. You'll find the Logger utility. It's an open source utility. It was originally written by a guy at Oracle named Tyler Muth. Martin D'Souza now manages the Logger utility. It basically gives you everything you could ever possibly want. And so what you can do is just download this utility, get management approval. It's very widely used. It shouldn't be that much of a challenge for you. And then you can simply say log the error, log the parameters, et cetera, et cetera. The whole UI, the whole API is built in there for you. And you've got a generic error logging utility at your disposal. All right. Any other questions before I move on to my next soapbox?
Just very quickly, someone's asking about unable to extend errors. And the basic problem there is you've run out of space. So you need to look at whether your data files are large enough, whether the underlying disk, you've got enough space on the underlying disk to see whether or not that can actually help you. We'd need a lot more to figure out exactly what's going on there. We need more information, but very briefly, speak to your DBA, sysadmin, see what storage space you've got, and approach it that way. So back to you, Stephen.
Thank you. And here's a question coming in. Is it advisable to use commit inside a procedure often rather than committing it outside in the calling subprogram, or maybe doing an auto commit? Mm-hmm. I'll answer first, then Chris, feel free to dive in. So my suggestion is that partly depends on the kind of code you're writing, but in general, your code should not contain commits or rollbacks. Leave it up to the user or your environment. So if your exception goes all the way out on handle, which it probably shouldn't, then a rollback will occur. But primarily around the commit, in these days, especially for any kind of web-facing application, first of all, every individual communication with the server is its own statement and does commit automatically. So that's one thing you need to be aware of. And second of all, in general, users decide what the transaction is and when they want to save them. So I'd say that if you've got a lot of commits all over your application, you're probably doing something wrong, unless you've got a batch process. And there are certain points at which you need to or want to make incremental commits. So in general, my suggestion is avoid having commits inside your PL SQL backend code.
Yeah, I'd agree with that. I think one thing to be aware of is the more commits you have in your code, the less reusable it is. So you think, I've got an insert order procedure, and that's a transaction, insert order. And then later it comes along that actually you want to create customer and insert an order at the same time. And that becomes a new transaction. You go, oh, hey, I've got this lovely insert order procedure over here. Let's just reuse that. But it commits. And that downstream, something that happened after it, as part of that larger transaction, there's a failure. And now you've got a half-complete a transaction that's half saved and half failed. So the more commits you've got in your code, the less reusable it is. And you should only really use it if you're absolutely certain that this is a transaction and this is the way it's always going to be.
That's a great point. And just one other little side point to that. If you are going to put a commit, or you feel you need to put a commit into your procedure or function, then make it an autonomous transaction. So one of the things you can do, and this is certainly if you're going to build your own error logging utility, for example, this is the classic use case for it. I need to write a row into my log table and save that log, because if I then do a rollback because the business transaction failed, I don't want to lose that row. On the other hand, I can't just generally commit that row, because then I will commit whatever partial transaction is in place. So what you can do with PL SQL is inside your procedure, include the Pragma autonomous transaction. And what this says to the runtime engine is that any DML that occurs inside the scope of this procedure execution, notice I'm actually calling another procedure to do the insert, but that's within this autonomous Pragma, then these changes have to be committed or rolled back before that procedure terminates. So it's a self-contained transactional unit. So that way, you were just talking, Chris, about making the piece of code more reusable. If it's got this commit in it, it might cause a commit across the entire session, which you don't want. I would say that the best solution is avoid commits unless they're actually required. If you do need to commit, put it inside an autonomous transaction. And then it actually is quite reusable. If you think about the distributed architecture that people are pursuing these days with microservices, for example. Well, if you think about a PL SQL procedure as being part of a microservice architecture, it really should commit a rollback. It should be a self-contained unit of work. And that's how you can do it in PL SQL. All right, just a couple of minutes left. And I don't think we have any more comments. I'd recommend to use two types of packages, one for external use and one for internal use. Interesting. So Dennis is talking about having a layered approach to the packages, in which you've got a back-end set of packages that don't have any commits, and you might have a layer on top of that that may do some specific commits for specific transactional purposes. Good idea. So my closing comments on error management. So we've talked about a number of the features in the PL SQL language and SQL language for error management: log errors, save exceptions with FORALL, all the different best practices I was recommending at the beginning about things to watch out for and take care of. So that's all important to know. But the other part of exception handling, which I think is so important, is to recognize the challenges around the psychology of exception handling. So I think humans are particularly ill-suited to do really good exception handling. And that's because what you have to do is be thinking into the future. I'm writing code now to solve this requirement. I don't want to think about the bad stuff happening. I don't want to think about things going wrong. And it's hard to project a month into the future when the users are using this application and what could go wrong. So we tend to psychologically diminish the importance of, or the need to prioritize, exception handling in the moment, because we live in the moment. So my suggestion around this is to always think about what could go wrong. It's not a fun thing to do, but the more proactive you are in terms of protecting your code, bulletproofing your users from seeing the errors, and making sure you're logging everything you need, that will save you a lot of headaches and time down the road. And I speak from personal experience every single day, because I'm one of those classic coders who is very busy, lives in the moment, and just thinks to himself, this is never going to go wrong. This is always going to work just fine. So try not to think that way, or recognize when you're being a little bit too optimistic. Get a hold of a reusable error logger utility like the logger or your own, but never write inserts into your log tables and your exception handlers. And make sure you understand the mechanics of exception handling in PL SQL. Chris, anything else?
No, I think that's a great summary. Code defensively, protect your users, give them meaningful error messages, because you don't want to be like on Twitter or something when, I think it was Target or someone, they had a receipt and on it was no data found.
Yes, not fun at all. And I got to say that can happen sometimes in my apps. Okay, so to finish up, what I'm going to do is quickly go back into Office Hours. So thanks for joining us today. Next month, it's time to talk about fetching a single row. So it's this classic question that people have: what's the best way to fetch a single row inside PL SQL from the database? And fascinatingly, there's one answer which goes along the lines of it depends. So we're going to explore all the nuances of fetching from a single row when we come back next month. In the meantime, thank you so much for joining us. We hope you got a lot out of this PL SQL Office Hours session, and we look forward to seeing you again. In the meantime, stay in touch, and happy coding.